Hello students, in the previous part we have covered the definition of set. A set is a well-defined collection of distinct objects. By well-defined, we means that the criteria for membership in the sets are clear and ambiguous, meaning there is no confusion that whether a particular element belongs to the set or not. And second thing, they should be distinct. The element in the set should be unique and identifiable. So this much we have learned. Now let's see some commonly used set in mathematics, and we will use this set very frequently throughout this book also, and throughout whenever you are learning mathematics, you will use this set very frequently. So the first set is N. This is the set of natural numbers. So the set N is the set of natural numbers. So meaning 1, 2, 3, 4, and so on, right? And next set is Z, the set of all integers. So in this we have 0, plus minus 1, plus minus 2, plus minus 3, and so on. The set Q is the set of all rational numbers. So all the elements of the form P by Q, where P and Q are integers and Q is not equal to 0. Next set is the set of real numbers. So all the numbers that you know till now are real numbers. All the rational, irrational numbers together, they are called real numbers. Okay, all the rational and irrational numbers. All the numbers that you know, natural number, integers, rational, irrational, all together are real numbers. Similarly, Z plus denotes the set of all positive integers. So 1, 2, 3, 4, and so on. So again, it's also, you can also say that this is natural number. Q plus are the set of all positive rational numbers. So here P and Q should be positive integers. P and Q should be positive integers, meaning 1, 2, 3, 4, and Q should not equal to 0. And R plus denotes all the set of positive real numbers. So these 7 sets, you will use them very frequently, and these notations are acceptable everywhere. So if it is not mentioned and it is just given that N, so you can imagine that this is the set of all natural numbers. Now again, let's discuss some examples of collections which does not form a set. So let's take an example. Just a second. One more thing, all these collections form sets because they are distinct and they are well defined. There is no confusion. If you write something, suppose you write cup, so you know that this does not belong to the set of natural numbers. If you write minus 1, you know that this does not belong to natural number. If you write 1, you know that this belongs to the set of natural number. If you have written anything here, X, Y, Z, whatever, horse, monkey, you know if this thing belongs to in this set or not. All the given sets. So all the sets are well defined. All the collections are well defined and distinct. So all these collections form a set. Now let's see some examples of collection which does not form a set. So let's take an example. the collection of 5 most renowned mathematicians. Now, you need to name 5, you need to collect 5 most renowned mathematicians. So this is not a well-defined property. This is not a well-defined property. This most renowned is not well-defined. Because you don't know, you can only put 5 names over here. So for some people, someone else are most renowned, and for some other people, someone else could be most renowned 5 mathematicians. So this does not form a set. Now let's discuss a very interesting real life example that will just tell you exactly how the set forms, how you should identify if a collection is a set or not. Okay, so let's think about the collection of all potatoes in the world at this very moment when we are talking. At this very moment, if we define a collection of all potatoes in the world, it is a set. There is no doubt that this is a set. Why? Because every potatoes that exists right now can be identified as part of this collection. So it's well defined. Because we know that only potatoes belongs to this set. Nothing else like carrot. Carrot does not belong to this set. Right? Does not belong to this set. So only if something is a potato at this moment, that would belong to the set. And other than that, they would not be belonging to the set. Now, if we change our terminology a little, if we say, now we want to create a set. Now, we want to create a set of 1 kg potatoes from this collection, the set that we just formed from this set, the collection of all potatoes in the world at this very moment. Now we want to create a set of from this collection, the set of 1 kg potatoes. Now can you think if this would form a set or not? This would not form a set because you need to collect potatoes from this set that weighs 1 kg, right? So you cannot clearly identify which specific potatoes should be included in this 1 kg potatoes. You cannot easily distinguish which potatoes to pick out from the entire world collections without a clear rule or boundary. However, if you have 1 kg potato in your house and you want to make a set of that, now you can easily identify each one. So you can create a well-defined sets from these potatoes. This is because you can clearly distinguish the elements that belong to your set, that is in your house, the 1 kg potatoes in your house. So this example clearly show how you make a set, how you define it. What does well defined means? What does distinct mean? Okay. Now let's see some notation and terminology used in sets. So when we say objects, when we say elements, or when we say members of a set, this means same thing. Objects of a set is also means element of a set and members of a set. So they are synonymous terms. You can use any of these. Now sets are usually denoted with capital letters like A, B, C, X, Y, Z, P, Q, whatever. Usually we relate it with capital letters, capital English letters. And the elements of the set, element of the sets or objects of the sets or members of the set, they are represented by small letters like A, B, C, X, Y, Z, P, Q, etc. Now, when we say A belongs to A, suppose A is a member of a set A, and when we say A belongs to A, we write it as A belongs to A. So this Greek symbol, this epsilon, in set, it means belongs. And when we want to say, suppose we want to say that B does not belongs to A, then we will denote it as A does not belongs to A. Sorry, not A, B. B does not belong to A. So this symbol means does not belong. Very important symbol. Belongs to epsilon, does not belong to epsilon and across. So, in the set of vowels, suppose we denote it as V, the set of vowels in English alphabet. So, what are they? A, E, I, O, U. Okay, just a second. So, this is a set of vowels A, E, I, O, U. So, now we can say that A belongs to V. And we can also say that B does not belong to B. So this makes to write these terms very easy. So these are two terminology belongs to. So we use this sign for belongs to and does not belong to. And we represent the name of the set as the capital English letter and the element of the set as small English alphabet letters. So this will conclude this video, and in the next video we'll see the methods of representing a set. Thank you so much for watching, and if you have any questions you can ask in the comment section. Please like, share and subscribe. Thank you for watching.